Welcome to 4.6 Systems of Linear Inequalities. We're going to solve systems of linear inequalities in two variables. Remember that inequalities is different than linear equations. So we've been solving linear equations, right? And we've had maybe like a 3 by 3 or a 2 by 2, and we've worked to solve those equations. But now inequality is when we have not an equal sign, but a less than, greater than, or equal to sign. So let's just refresh our memory on graphing a linear inequality, because we're going to have systems pretty soon where we have more than one. So let's just focus on one and graphing it. So remember, we want to try to put it in slope-intercept form, where the number in front of the x is the slope, and b is the y-intercept, not the x, but the y. So we always want to plot that first point on the y-axis. Here it's -1, so I go down -1 on the y. Then I'm going to follow my slope here. So I have -1 over +5, which means I'm going to go down 1 and right 5 from that point. So down 1 and 1, 2, 3, 4, 5 over. Now I can't always just connect these with a straight line. I need to be careful of my inequality here. There are two things I need to remember. One, solid or dotted line, and two, the shading. So when I connect these, this symbol doesn't have a solid line underneath it, so I'm going to connect them with a dotted line. If it was an or equal to, if it had a line underneath, there'd be a solid line connecting them. Okay, so now I need to do shading. I'm either shading above the line on this side of the line, or I'm shading below the line on this side. So how do I check? Well, I can test a point like 0, 0 and decide whether it's true or false. So if I plug in 0 for y and 0 for x, what's going to happen? Well, I'd have 0 over here. 0 times -1/5 is 0. Minus 1 would be -1. Is that true? Is 0 less than -1? And that's false. So what does that mean? That means 0, 0 is not a solution. I don't want to shade to that side of 0, 0. So I want to shade to this side. The other way people know is this less than symbol. I want y's that are less than this line. So the y's up here, those are bigger than the y's down here. I want the less than y's. So I want to shade all of these y's that are going to be below the line. Okay, so that's a refresher on how to graph linear inequalities. Let's look at a system. Remember, a system is two or more inequalities. So this wants us to sketch the graph of the system. In order to sketch this, though, I need to get these in slope-intercept form. So I'm going to start with the first one, the top one. 2x minus y is less than or equal to 5. If I'm going to get it in slope-intercept form, I need to get y by itself. So I'm going to move the x away, or to the other side. That way they zero out, and the y, negative y is left here. And I have 5 minus 2x. Those are not like terms. I can't combine them. I'm going to write the x first and then the +5 second, just so that it looks more like slope-intercept form, where the x comes first and the number comes second. Okay, so now y isn't by itself. There's a -1 in front of it. So I need to divide by that number, -1, on both sides. And I'm not just going to divide the -2 or just the negative or just the 5. I'm going to divide both of them. So now the negatives cancel and I'm left with y. One thing that I want you to remember is when you are dividing by a negative on both sides, you need to flip your inequality. So instead of facing that direction, I'm going to flip it to face the other direction. A -2 divided by a -1 would be a +2, and there's an x with it. And a +5 divided by a -1 would be a -5. So I'm going to write -5. So that's one of my lines. Let's do the other one. I'm going to put it in slope-intercept form. Again, we always want to move the x first before we get rid of the 2 in front of our y. I'm going to write the minus x first and then the positive 2, just so I can see slope-intercept form better. Divide by 2 to everything. And I'm just dividing by a positive number, so I don't need to flip my symbol. I have a negative 1x divided by 2, so I'm going to write negative 1 over 2x. And then a 2 divided by 2, that's a 1. So I have my second line. Okay, so now let's sketch the blue line first. I'm going to go to negative 5 and plot a point because that's the y-intercept of the blue line. And then the slope is positive 2, so that's like a 2 over 1. So up 2 and right 1, up 2 and right 1. And I want to decide dotted or solid here. So because it's an or equal to, I'm going to connect these dots with a solid line. And that wasn't very good. And then I want to decide the shading. Okay, so it says y is greater than this line. So which side of the line are the y's greater? Well, on this side of the line, I have y's such as 1, 2, 3, 4, 5, and on up. If I were to shade on the bottom side of the line, and remember this line goes on forever, I'd be getting numbers down here like negative 10, negative 20, negative 15, negative 6. Those are smaller numbers. Okay, so which y's are bigger? Well, the y's in blue instead of the y's in yellow. So I am going to be shading above this line. So for now, I'm just going to draw arrows above it. So I remember I want to shade on that side for the blue line. Let's plot the red line. I'm going to do the y-intercept first, so go to positive 1. Follow the slope. It says negative 1, positive 2. The negative in the numerator means down, right? Because the numerator is up or down. If it's negative, I'm going to go down. The denominator tells me left or right. If it's positive in the denominator, I'm going to go right. So down 1 and right 2. Down 1 and right 2. Now, how do I connect this line? Well, again, it's an or equal to. It has a solid line underneath. So I'm going to connect with a solid line for the red line. Now to decide the shading. So again, this is y is greater than. So you have to think, are the y's up here greater or are the y's below this red line greater? Well, below the red line, you have numbers like negative 5, negative 4, negative 3. Above this red line, you have 2, 3, 4. Those y's above it are greater. So I'm going to end up shading above the red line. Now another way, remember you could test the point, 0, 0, and plug in 0 and 0 for y and x, and see if it's true or false, inequality. But I'm going to use the shortcut method. Okay, so now the solution to this system, remember the solution to a system of linear equations was an ordered pair. You got an x comma y that satisfied both equations. Now the solution to an inequality system is the area that's shaded by both graphs. That's the important part, both of them. Okay, so I need to be above the red line and above the blue line. So here's above the red line and here's above the blue line. That's the region that's shaded by both of them. Because notice that over here, in this question mark area, that's above the red line, but it's below the blue. So it's not satisfying both. It's only satisfying the red. And over here in this question mark area, it's above the blue, but it's not above the red. And obviously, this isn't satisfying either of them. But this upper left corner here, that's satisfying red and blue. It's both of them. So that's the solution to my system. Let's look at another one. Y is less than 4 and y is greater than 1. Believe it or not, these are actually lines. Remember when we had y is equal to 4? That would have been, hitting the y-axis at 4, and it's a horizontal line. Same thing with y equals 1. That's going to be hitting the y-axis at 1, and it's a horizontal line. Okay, but I can't just draw a straight line. I need to check solid or dotted. So on the blue line, 4, it doesn't have a straight line underneath, so it's a dotted line. And we said it's horizontal. Same thing with the red line, it's going to be dotted because it's just a greater than symbol, not an or equal to. Okay, so shading. Y is less than 4, so which side of this blue line are the y's less than 4? Well, the y up here is 5 and the y down here is 3. 3 is less than 4, so I want to be below my blue line. Let's check the red line. It says y is greater than 1. Up here is 2 and down here is 0. Which side is greater than 1? Well, 2 is bigger, so I want to be shading on the 2 side. So I shaded both of them. The solution is the area shaded by both lines. So the area shaded by both lines would be below the blue, above the red. So anything in here is a solution that will work for both inequalities. I have an infinite amount of x and y's that are going to work. Right? I could pick this guy. He's 2, 3. He'd work here and he would work here. I could pick this guy, -4, 2. He would work here and in this inequality. Any x and y value in this yellow shaded region is going to work for my system. I want to point out that on a number on a solid line is part of that system, right? So that point there is on the red line, it's part of the yellow region. This point here on the blue line, it's part of the yellow region. However, if you're on a dotted line, like here, or even here, or here, or here, those are not going to be solutions. They're on a dotted line. It's kind of like an open circle, right? In your inequality, it's like an open circle. It's not a solution, but a closed circle would be a solution. Okay, so if it's on a dotted line, it's not going to work, but if it's on a solid line, it will. If you have any questions about that, please raise your hand now and I will come around and help you. All right, let's try one more. Actually, we're going to try a couple more, but let's up the ante. Instead of 2 lines, let's now do 3 different lines. So the first one says x minus y is less than 2. I need to put it in slope-intercept form. So I'm going to let you go ahead and do that now. Be careful if you have to divide by a negative. Okay, hopefully you subtracted x and then divide by -1 and remembered to flip your inequality symbol because you're dividing by a negative. So you got y is greater than x minus 2. Now your other equation says x is greater than -2. That's already in slope-intercept form. The variable's already solved for. And your third equation, I'm not going to use yellow. Let's use purple. Says y is less than or equal to 3. That's already in slope-intercept form. The variable is by itself. So we just need to plot these. So I would go to -2 for the red line, and the number in front of x is a 1, so it's a 1/1 slope. And how would I connect these, solid or dotted? And yes, that would be a dotted because it's not an or equal to. Then let's do the blue line. This is x is greater than -2, so it's crossing the x-axis at -2. It's a vertical line. And this is not a solid line. This would be a dotted line. And the purple is going to be a horizontal line. It crosses the y-axis at 3. And this one is a solid line because it's an or equal to. So now I need to consider shading. Well, let's go back to the red line. Y is greater than x minus 2. So which side of the red line, this way or this way, are the y's greater than? So I'm going to be shading above my red line somewhere. Greater than. Blue says x is greater than negative 2. So which side of the blue line are the x's greater than negative 2? So I have x's on this side. Take a look at those numbers. And I have x's on this side of the blue line. Take a look at those numbers. Which ones are greater? So obviously we'd want the right side of this blue line. And then we have the purple line. Y is less than or equal to 3. So do we want those y's up here like 4 and 5, or do we want these y's down here like 2 and 1? Which y's are less? 2 and 1 would be less. So we're going to shade below this purple line. Now remember, after we kind of have an idea of where we want to shade all three of them, we need to graph the solution. So we don't want any extra shading. We just want the area shaded by all three lines. So where is that overlap? Where is below the purple, to the right of the blue, and above the red? Well, that's going to be in this triangle. Below the purple, above the red, and right of the blue. This is my solution. This is the area shaded by all three. And if you like to be clean, you can erase those other arrows. If not, that's fine too. WebAssign is not really going to matter. You're just going to have to click an area to shade. All right, we can do the same thing when a system has 4 equations. We're just going to be graphing 4 different lines. So one thing I want you to notice is that one of your lines is x is greater than or equal to 0. The reason I picked this problem is because of these 2 lines here. So how would I graph x is greater than 0? Well, it's crossing the x-axis at 0. So here's the x, find 0. And it's going to be a solid line. Remember, x equals is a vertical line, and anytime you have y equals 0, or sorry, it doesn't even have to be 0, just y equals a number, any number, it's vertical, and sorry, x equals is vertical, y equals is horizontal. And we've already seen this, but let's look at what it means when it's 0. So it's a solid line, vertical solid line through 0. And if I'm talking about shading, x is greater than 0. So these x's on this side are greater than these on this side. So I know I'm going to be shading to the right of this line. And when it's y equals 0, it's crossing the y-axis at 0. And again, it's a solid line, and it's y equals, so it's horizontal. And I know that y is greater than 0, so these y's up here are greater than these y's down here. So I'm going to be shading above this blue line. And so just know that we're already talking about this region up here. It's satisfying both of these 2 lines. Now we're going to incorporate 2 other lines. To add into the mix. Okay, so start by taking the top equation and putting it in slope-intercept form for me. Okay, hopefully you subtracted x, and that's all you need to do because then y is by itself. You didn't even have to flip the symbol, so y is less than or equal to negative x plus 5. You could have written 5 minus x, but then it's harder to see what's your slope and what's your y-intercept. That's why I keep writing the x first and the number second, because we have mx plus b form. Now go ahead and put the second equation in slope-intercept form for me. Okay, hopefully you subtracted 3x and realized that you can't combine a 12 with a 3x because they're not like terms. And hopefully you wrote the minus 3x first and then positive 12 next. Then after that, you're going to divide by 2. It's not a negative, so you don't have to flip your symbol, so your symbol stays the same. And you're left with y. Then you have a negative 3 divided by 2. That can be written as a fraction since it's your slope. You need a rise and a run. Don't put 1.5. That really won't help you. And then 12 divided by 2, you can simplify to 6. So you have your fourth equation now that you need to graph. So let's go back and do the teal line. Y is less than or equal to negative x plus 5. So you're going to go to plus 5. That's your y-intercept. And then your slope is negative 1. And you can write that as negative 1 over 1. So you're going to go down 1 and right 1. You're going right because the 1 in the denominator is positive. You're going down because the 1 in the numerator is negative. So down 1, right 1. And how would we connect these? Solid or dotted? Solid because it's an or equal to. And when I consider shading, am I going to be above it or below it? Well, it says less than, so the y is less than, or the y is down here instead of the y is up here. So I'm going to be below. And let's do this rust-colored line. I'm going to start with my y-intercept at 0.6. You can just kind of picture a 6 up here. And then a negative 3 and a positive 2. So I'm going to go down 3 and then right 2. 1, 2, 3, right 2. 1, 2, 3, 1, 2. 2. And solid line because it's an or equal to. And I can't connect them. Okay. Shading here, again, it's y is less than, so the y is below it or less than the y is above it. So I'm going to be shading below this rust line. So my common shaded region. Okay, so above the blue, right of the red, and below both of these. So I need to be below the blue, the turquoise blue, and then below the rust color. So again, it kind of looks like a triangle, but make sure that you aren't shading in this area that I'm going to do in green. This area right here would not be shaded in. Why? Because it's not below the rust color. It's below this turquoise, but it's not below the rust. Don't shade in that, and then don't shade in this in green, because why? It's not below that teal color. So only the yellow portion would be the common shaded region. All right, let's kind of work backwards here when we are given a graph and we have to figure out the system. So obviously I have one line here for this boundary. I have a second line here, a third line here. The boundary is in blue. So I have 1, 2, 3, and actually I have a fourth line here guarding the blue from being shaded in more to the left. So I have 4 different lines. So I have 4 different equations. All right, let's start with the first one, this diagonal slanted line here. It says y equals negative 2x plus 12. Well, I know since it's inequalities, I'm not going to write equal, but it's going to be that same line. Right? It still has a slope of negative 2 and a y-intercept of 12. I just need to figure out what symbol goes here. Well, it's a solid line, so I know it's an or equal to. And now I just need to decide what shading, like, is it going to be greater than, or is it going to be less than that line? So notice that we're shading this away on this diagonal line. So is that less than? Are these y's less than these y's that are going to be up here? We'll just, either you can test 0, 0, or you can think about it logically. Like this y right here is a 5, and this y right here is a 3. So is 3 less than or more than 5? Well, 3 is less than, so you know that that y is less than or equal to. Okay, so we took care of that line. Let's jump to the second one. It's a horizontal line, and horizontal lines are y equals a number. What number is it crossing the y-axis at? Well, that'd be the number 4. Now we need to decide the shading, or sorry, the symbol, the inequality symbol. It's a solid line, so I know it's an or equal to. I just need to decide, is it less than or is it greater than? Again, let's test out some y values. So we are obviously shading in blue below this line. So this y value would be like a 3, and this y value up here would be a 5 again. So what are we talking about here? Well, we're shading in the number less than 4. We're shading in the 3, not the 5. Okay, so that would be, the y is less than 4 symbol because we shaded the 3. All right, let's talk about the third one. Again, horizontal line, solid. Where is it crossing the y-axis? Oh, it says right here, y equals 0. So shading, this time we're shading above it. So I know that these y's up here are greater than these y's below it. So I am using the greater than symbol. Y is greater than. Make sure your alligator mouth is eating the y. And the fourth one, it says x is equal to 0. Okay, it's a vertical line, so x is equal to a number. This time it crosses the x-axis at 0. And it's a solid line, so it's an or equal to. And we're on this side of the vertical line, so are these x's over here greater than or less than the x's that aren't shaded in? Well, that x value would be a 2, and this x value would be a -1. These are greater, so I want the greater than symbol. All right, so I just created from the graph a system of linear inequalities that describes this region out of those 4 lines. I'm going to go ahead and skip that for now. But what I do need to talk about, because it may be on your web assign, is a no solution graph. So a no solution graph for a system of linear inequalities would obviously have no shared shaded region or no intersecting shaded area. Okay, so for example, if you were given the system of inequalities, y is greater than 3 and y is less than or equal to 1. Let's look at this graph. So we have y is greater than 3, so it's crossing the y-axis at 3. It's a dotted line, and it's horizontal. Then we have in blue, y is less than or equal to 1, so it's crossing the y-axis at 1. It's a solid line, and it's horizontal. So let's talk about shading on the red. Y is greater than 3, so you need the y side that's bigger than 3. Well, that would be shading up here. And on the blue line, you need y's that are less than 1. Well, the y's less than 1 are the y's down here. So do they have an intersecting shaded area? No. Like in these graphs, we had a common region in yellow that could satisfy all of the lines. Well, this shaded region in red doesn't satisfy the blue line. It's not satisfying both, and the shaded region in blue doesn't satisfy the red line. So this would be a no solution case. Okay, there's no common region.